Okay, new stuff. These are application problems. And so basically in word problems, and yes, your next test that you have is called a communications test. It has some easy stuff on it, but it also ends with like 4 word problems. You got to get good at word problems in Precalc. You've had them for many years. I know many of you have hated them for many years, but I have a way, and if you follow this way of solving word problems, it works really well for this class. All right, so first thing is you always want to draw a picture of whatever the situation is. So if I say, I'm making a football field, everybody right now, sketch a football field. So hopefully you just basically went with a rectangle. Don't need it to be intricate. We don't need stands. We don't need the mascot. Okay. All right. So if I say I'm making a football field and I want it to be twice as long as it is wide, you right away should be able to label that with variables. You don't know how long the sides are, but you know it's twice as long as it is wide. Label that. Now some of you went with X and some of you went with W. It's fine either way. And this is twice that, so this is 2 X's. All right, so once you've got your sides labeled, then the next part is you have to pull in a formula. And that'll depend on what I tell you. If I tell you the distance around the field is blah, 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 then you got to pull out the perimeter formula out of your head. If it's the area of the field is going to be blah, 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 then you need the area formula. Okay, so you got to figure out which formula I want. In this case, I'm going to say the total area of the field needs to be 1,000 square feet. So right away, you write the area formula off to the side. And you should write it, don't shortcut. It needs the A equals. The area of the field needs to be 1,000. Well, A equals length times width. You write out the full normal formula. And underneath it, you put in stuff. Like, what did I say the area's got to be? 1,000. And the length. From my picture, I know the length. The length is 2x. And the width is x. So the steps are, again, you draw a picture. You label your picture. Then you figure out what formula you need. And then you stick the numbers into the formula. And then from here, it's solve. And there are some on the test. This is a combo test. Half the test you can use calcs, half you can't. If we make it easy enough, you should be able to solve it. Like this one, you should be able to solve without a calculator. Okay, 2xx, what's the other name for that? 2x squared equals 1,000. And if you're supposed to solve that, you're supposed to know how to do that. So we subtract, no we don't, we divide by 2, and you get 500 equals x squared. Am I done? No, x is not alone yet. Now what? Square root of both sides, and you're not going to forget that this is absolute value of x, are you? Square root of 500. And I don't know what that is. I wouldn't expect you to know it either. And then you're going to remember that that means there's 2 answers. X is the square root of 500, or x is negative the square root of 500. And which of those can we throw out in the real world? And this is an extraneous answer, so you'd write ext above it. That means that that's not a possible answer. So the answer must be the square root of 500. And now you've got to go back to, this is a really sad mistake when kids do this. If the question had said, what are the dimensions of the field, and they say square root of 500, did they give me dimensions of the field? No. They've given me one of the sides of the field. And which one did they give me? X. So they gave me this one, is square root of 500. So what's the other one got to be? 2 square roots of 500. So if they ask for the dimensions, I'd have to say square root of 500 and 2 square roots of 500 are the dimensions. And in the real world, that a lot of times comes out to, you know, you can grab a calculator and you get a decimal for it. But all right. So that's your steps. You start with a picture. You move to a formula. You take the numbers from your picture and put them in the formula. And then if it's easy enough, you solve it. And if it wasn't easy enough, you'd have a calculator. And then you graph both sides and what? And see where they cross. Graph both sides and see where they cross. All right. Mr. Yu, are you with me? Good. All right. So I'm going to give you some examples of words that it may be in a word problem that you need to translate into equations. Some of the questions are as easy as this, like R2 kind of level stuff. All right. So let's say that I have 5 more than 3 times a number. I just said some words. Change it into math. 5 more than 3 times a number. Now, a lot of people get confused with more than because they think it sounds like greater than. But if I say 5 more than 3 times a number, 3 times a number at least should stick out like this to you, right? And if I say 5 more than that, or I could add the 5 at the front. Would it make any difference? No, be fine. Raise your hand if you had that one right. Okay, good. Some of it is as simple as that, but you'll have to know a few words like quotient. Do you know what that one means? Divide. Better write that down if you didn't know it. Quotient. Quotient means divide. What does add, what's the official name for add? Addition is, yes, but there's another word. It's really short. Sum. Sum is fair add. How about product? Multiplication. So if they say the product of blah, 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 if you don't have times in your problem somewhere, you screwed up. Product means times. How about difference? Subtract. All right, so make sure you know those. All right, here's a typical question. 2 numbers add to 16. Well, I don't know what the numbers are, but I would not call them x and y. You want to keep it only as one variable, okay? If you're going to have 2 numbers adding to 16, I would, to begin with, I would write a total of 16 and x plus, a lot of times they're going to tell you something else about the other number. Like the other number is 3 larger than the first number. So then you'd say x plus 3. If you use 2 variables, it can work, but it makes it more confusing later because right now I'm ready. I can just solve this thing. I can multiply it out. I can get x squared plus 3x, bring the 16 over to the other side, minus 16 equals 0. And that's what you should do with all quadratics, by the way. Remember, set them equal to 0. It's huge, because then you can use a quadratic formula on them, or they can factor. Remember that? All right, so getting quadratics set equal to 0 is another big moment. Okay. There are so many word problems on this sheet that I don't want to like make up all kinds of new ones if I'm probably going to be like deciding whether or not to cut some of the homework problems, then I may as well be using some of these homework problems as real problems. So here it comes. This is your worksheet. This is actually 3 days of homework, so don't freak out by the size of it. It's 3 homework assignments all rolled into one. And yes, word problems are hard tests, but to be honest, they're not as hard as the algebraic manipulation tests for most kids. This isn't that bad. If you stick with my program that I'm going to show you about, make the picture, label the picture, make a formula, put the numbers in. If you follow my little recipe, these aren't that bad. All right, so let's do a couple off this sheet. The whole front side, I hope you feel like is elementary. Shouldn't be too bad. So let's flip the page and look at page 2 and start looking at the serious word problems. Yes, sir. Well, you want your test back? What? Oh, you're going to be fine. Okay. So number 17. Number 17 says, 2 numbers add to 16. Ooh, that sound familiar? Write an expression for the product of the 2 numbers in terms of only one variable. All they said was that they add to 16. I cannot do this. X plus x equals 16. Because that means that they're the same number. Okay, you can't do that. All right, so how do I add? How do I have 2 numbers being added together? One of them's x, and one of them's something else has to add up to 16. You can do it, can't you? 16 minus x. Now, let's think about this for just a second. How did she get that? How did she pull that out? Okay. How about this? If I had said, just ignore this whole math thing and said, I have two numbers that add up to 16. Okay? And I had picked one of them in my head. Let's say it was going to be 7 or something. How would you get the other one? 16 minus the 7. Do you get what I'm saying? So, if we pick it to be x, the other one's got to be 16 minus x. Now think about this. If you add those together, doesn't it just logically follow? Because look, the x and the minus x are going to cancel each other out. And it's going to be 16 equals 16. Okay, so if I had said, for instance, two numbers add up to 20, what are they? You should say, oh, they're x and what? 20 minus x. Those must be the two numbers if they add up to 20. Because if I take this plus this, think about it, what will it equal? The plus x and the minus x will cancel. It'll equal 20. Okay, two numbers add to 34. I know I'm pounding this in, it's kind of relentless, but it'll help when you get to the test. So two numbers add up to 34. What are they? X and 34 minus x. Good. And their product is 100. Product means multiply them, equals 100. Did you see what just happened there? I said two numbers add up to 34, x and 34 minus x, and their product, multiplying them, is 100. See? And now I could solve that. I could multiply that out. Let's try that again. Let's say I said two numbers add up to 50. Well, right away you should think what? X and 50 minus x. Okay, and they also have a difference of 6. Let's subtract, and what do I need around these guys? And the difference is 6. See? Okay. All right. I think that should cover you. You should be able to handle things like 18, 19, 20. And for today, life is fairly easy. You're just assigned the first two sides, so it's problems 1 through 24. Okay, I know that's a lot, but the first ones are super easy. Okay, let's start on the front side together just to make sure you see how easy they are. Like number 1, 5 more than 3 times the number. 3 times the number, 5 more net, plus 5, done. That's it. That's all you got to do. Nothing really hard in the front side. Number 2, a number increased by 5, n increased by 5, and then what does it say? Then tripled. Ooh, this is important. Then tripled. Wait, that's not tripled. There you go. All right. Number 3. 3 times the difference between a number and 13. Sometimes it helps to start partway through the problem. The difference between a number and 13. What should I do there? N minus 13 or 13 minus n? You could kind of argue that, but I'm going to say n minus 13. And then 3 times that. Get used to the parentheses. You need those parentheses. Otherwise, you'd just be timesing the n by 3, and you don't want that. Okay. I think you're going to be all right. Today's is pretty easy. And then tomorrow we're a step up to the bigger time on Wednesday. And then on Thursday, we get to the really challenging ones. And then, just so you know the big picture, Friday is, you guys are not here. Okay, I'm here, but then we'll see you again on Monday. And Monday's a review, and then Tuesday's a test again. It's on this. And also on the order that you do problems in. It's called a communications test. And you've never been tested on what order to do this in. So I want to just take a second to remind you. Let's say you had this problem, and I think you all know that that's a parabola that's been moved. I hope you know these things. What's that? Left 5. And then when you get to the outside, what should be first, the A clump or the B? A should be first because it's multiply stuff. So then of these two, they actually can be in either order. It does not matter. I recommend you stretch things before you flip. So I recommend that you do this next, and then the flip would be third, and then the last thing you do is this. So if you were given a problem like this, this is where everybody screws up on the inside. So this is a parabola. And people get confused by this middle part because they are not sure what order to do it in. You got to ask yourself, please excuse my dear Aunt Sally, are there any parentheses inside here? No, so there's no parentheses. So then you move to the next thing. What's next? Parentheses, exponents. Are there any exponents inside here? No. So you're using PEMDAS, but when you're on the inside, you do in the opposite of normal order. So this should normally be first right here. So it's not first. That would be first. And so you'd have to make a list, and you go like this. Number one thing I should do then is go right 5, because that's this. Then I should do the 2. So that should be, and that's not twice as wide. Everybody screws that up. It's half as wide. The third thing you do to your parabola is you move to the outside and you do this because that's a multiply. And we do things on the outside in normal order. So this would be a reflect over the, it's up down, so that's over the x. And the last thing would be to move it up 6. I know some of you weren't listening to that, but hey, it's your life and your test that you have to take on Monday. So that's how you do things in the right order. We'll practice it again tomorrow. I encourage you to pay attention so that you don't screw these up. They should be the easy ones, but a lot of kids get them like one thing reversed in the middle and then it's all wrong if you had those two switched, for instance. Okay, that's all I have for the video for today.